Problems? We're out of here right at 25, right? Yeah. We're out of here in 25 minutes. So, the practice and homework is posted. We're not going to do it until Monday. So, all we need to do is go through these slides, a couple examples, and whatever time we have left, then we'll have a free day for whatever time we have left. All right? So, today, actually, even what we're looking at today, you guys pretty much already know. Sorry. We're talking about, well, let's think about yesterday. Yesterday, well, we talked about it a little bit yesterday. There's that question on the quiz. Is anyone in here not taking the quiz yet? There's a question on the quiz. We got. There's that question on the quiz that had a triangle like this and a triangle like this. Right? And then the side, I don't remember exactly what the side lengths were, but I'm pretty sure the ratio like matched up for each of the side lengths. And you had to say, are these triangles similar? And it was just yes or no. Does anyone remember this question?
I think it was the side lengths were 6 and 6 and the smaller one, and then 8 and the other one.
Oh, okay.
4 and 6.
Okay. So what was this question trying to get at? I know it gave you the side lengths, but that was not what the question was trying to get at.
I know what it was.
Oh, what was it trying to get at?
It's trying to show you that the length or the proportion, the whole triangle.
Not necessarily. The answer was no.
Yeah,
Oh, I get it right.
I think it was showing that the two angles are similar. The two angles have to be the same, right? To be
Yeah.
similar.
What it was trying to get at is the two angles have to be congruent, right? Two angles from each triangle have to be congruent in order for the triangles to be similar, okay? In this picture, the reason that it's no is because we have these little lines that are telling us that the two angles inside of the same triangle are similar to each other. It didn't tell us about any angles on the other triangle, how they are related. So up to yesterday, the only way that we could tell whether two triangles were similar or not was by looking at their angles, right? We talked about the angle-angle theorem, the AA similarity theorem. Now today we're building off that, and we're going to be able to show that two triangles are similar by side, 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 which we've talked about a lot in the past, and side, angle, side. Super sweet. Today we need to know the side, side, side similarity theorem, side, angle, side similarity theorem, and then we're not really going to talk about this last part very much. We're really going to focus on side, 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 angle, side. As a review, when have we used, let's start with, well, we can put both of them together. When have we used these two things, side, 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 and side, angle, side, before? Okay, there's a start, GOA. What specifically did we use them for? Thank you, Nate. Is that a hand, Kylie? No? Okay. Come on, what do we use side, side, side for? We had two triangles.
Oh, I know.
Yeah, if we had two triangles and all three sides were the same length, we were allowed to say then that those two triangles are congruent. Very good. Side, angle, side. What was the key to side, angle, side? Like, if we had this triangle here on the left, would this be side, angle, side right here?
No, sir.
No. We had to have, what was the word? We had to have the, starts with an I.
Independent.
Not quite. Well, we do need to be intelligent, yeah. And we also need to be, inclusive angle. So in order to use side, angle, side, we had to have the side, the inclusive angle, and then the other side. Is this all coming back to you now? Remember GOA, right, Nate? GOA?
That was first term.
From Geometry A, yeah. So we're going to use side, 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 and side angle side to say that two triangles are similar this time. Not congruent, but similar. Remember, similar means that they have the same proportion with each side, and that they have the same angle measures, but they could be different sides. So, our first theorem, we can use side, side, side. Similarity theorem. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. So if each of the side lengths, corresponding side lengths, have the same proportions, then we can say that the two triangles are similar. This should not be shocking. Right? To get from A to B to RS, we multiply by 1/2 every time. To get each of the new angles, we multiply by 1/2, and it's fair to say that these two triangles are similar. Alright, so here's what an example problem would look like. Is either DEF, so is this triangle, or the second triangle, are either of them similar to ABC? We need to figure it out. If we first look at DEF, if we look at the first triangle, what the strategy the book gives us to try to decide if these are similar or not and try to start to match up sides is we want to take the shortest side from each triangle, the longest side from each triangle, and then just the leftover side. So if we look at triangle ABC, what is the shortest side? Good. Or 8. What about with DEF? What is the shortest side? Okay. What is the longest side of ABC? 16. And then 12. And then what's left over? 12 and 9. So we just set up a proportion with each of the corresponding sides with the shortest, longest, and then the leftover side. Now if we simplify these, we would have 3 over 2. No, that would not be 3 over 2. That would be back up. 4 over 3. 4 over 3. And 4 over 3. So since all of these ratios are the same, we could say that triangle ABC is similar to triangle DEF. Questions on that? Now technically to finish this question we would need to check triangle 2 as well. So if we quickly match up the shortest side from, we'll call this, well, this is our original sort of triangle. We look at ABC, the shortest side we already said was 8. The shortest side in triangle 2 is also 8. The longest side is 16. We already said in ABC. In triangle 2, the longest side is also 16, so things are looking pretty good so far. Leftover side is 12. Leftover side is 10. Is triangle ABC similar to GH?
No.
No. Why not? Which side gives it away?
The leftovers.
Yeah, the leftover. We don't have the same proportion throughout. Good. Now they could do the same type of thing, except now we would involve x and have to solve for x. Find the value of x that makes these similar. So what do you think would be easier, to solve for x here with BC or down here with DF? Which one would be easier? Probably. That's what I would do. BC. So let's set up a proportion that has BC involved, and then we can solve for x. So we can go AB is 4, for, and which side in DEF is AB corresponding?
DE.
What?
DE.
Yeah. Over, and that corresponds to EF, so 18. So we have our proportions set up. We would cross multiply. And we could solve for x. Right? We could solve for x. Yes. Good. And thing, if I remember right, x ends up equaling 7.
But I can't do 18 times 4 in my head. It'll be 72.
X equals 7? Yeah? Okay. Perfect. X equals 7. Go ahead. If you haven't logged on already, there's the code. Try those couple problems. And then we will look at one more theorem. Yeah. One more theorem, one more example. See you later. Oh, and then there's one more slide of practice problem. Your only job today is absorb information, and you have 4 problems that are your assignment. I think we're going to be okay. For which one? You could set it up a couple different ways. Yeah, that's okay.
Oh.
What's the matter, Caleb?
My brain I was
Allie got started. Why is our page empty? Braden, why is your page empty? That's not a good reason. Cole's got some work.
I'm trying to figure out what the smallest determiner.
Well, it's
I said that wrong.
Nice job.
I'm trying to figure out what this.
Good, Mia. Nate, let's go. Get to work. Is that on paper? That's fine. You can just put your take a picture of your work. Nick, oh, you're on paper too, aren't
I'm trying to figure what the smallest of.
Alton, what are we doing? Will, I don't care. Butterflies. I don't care about butterflies. Let's go.
I have a question.
Yeah, Kylie.
I'm trying to figure out how to shorten this to the smallest, and I'm struggling. Or did I pick them up? Did I do it?
Good, yeah, good.
I'm trying to figure out what
So
this
we just want to have separate. We don't have to write them. Where's my pen? So like
You take the shortest and the longest of these triangles that you said?
shortest, longest, left over. Hey, I'll make it a little easier. Don't worry about the last triangle. Just compare the first two. And number 1, you don't have to compare all 3 triangles. Just compare those 2.
I do it in my own way, okay?
Some people need some encouragement here.
I'd rather do this. That's
What were you doing while I was doing the example?
Paying attention.
I don't think so.
Little bit.
Yeah.
And alleys.
Yeah.
Sorry.
And I was writing down exactly what you wrote on my paper.
Dude.
Oh, this one.
There you go.
What are you doing right now, Will?
What?
I mean, comparing this is for my where my
Okay.
goes.
No, that's not anything. Let's go. I already matched them up. Now I just need to see if the ratios are the same.
How do we do that again?
No!
Wait,
We didn't cross multiply anything. We just need to check the ratios.
how do you do that? Just divide?
I struggle on trying to simplify stuff like to its multiply.
You guys,
Oh,
we have two triangles. We're trying to see if these are similar using side, side, side. Okay? We take the shortest side in each of the triangles, which is 20 over 24. We take the longest side. We take the leftover. Now, we need to see if these proportions are all the same. If all these proportions are the same, then we're all set. Then we've got side, side, side. If they're not all the same, then out of luck. We don't have side, side, side.
I'm just trying to
These
figure out
triangles
how
are
to.
not similar.
How do you simplify fractions again?
Oh boy. We need to know how to simplify fractions.
One thing, Mr.
Hey,
I'm very new.
Alton, I don't think you know how to set these up. So,
I know how to do something.
yeah. But you know how to simplify fractions, so it's okay. I think, is that in simplest form? I think
Yeah.
that's in simplest form.
If I put them in the decimals, will that work?
Yeah, that'll work.
Okay, good.
Let's see, what is this one?
6.
6? No.
Not 6 and
No.
It's 4 and 5.
5 here, 4 there.
They're not similar.
So they're not similar.
No.
We don't have the same proportions.
Oh, well, yeah.
Oops.
So I just write 9.
Very not similar. But you gotta show something. Well, for this you don't, but homework. Okay, we're moving on. You'll have to come back to that. It'll take way too much time. Side angle side. If an angle of a triangle, if an angle of one triangle is congruent to an angle of the second triangle, and the lengths of the sides of the included sides, right? Very important. The included sides. Yeah. The included sides are proportional. Then we can say, yep, side angle side, we've got similar triangles. Okay, let's look at an example. Oh, this is a real life example. Alton, this could be you over the weekend.
Wow, what am I building?
Or you will.
Wow, that looks like something you could talk to.
Actually, me and Will are planning on building one of those.
You were building a lean-to shelter. I thought it was a ramp.
I thought it was a ramp.
Yeah, I know. You were building a ramp.
Why would we build one?
It's starting from a tree branch, as shown. Can you construct the right end so it's similar to the left end using the angle measure and the length shown? So good thing you have your protractor at home, or Will probably has one.
Yes.
So then you would be able to find the measure of those angles.
What happens when the range is
Well, that's why it's a ramp and not a lean-to. Also, this is just not working.
It's like a weird launcher.
Oh, where
You sit on the ground and use that as the backrest.
Yeah.
Oh, I see.
That's a good idea.
Like a launcher that's not adjustable.
What we're
That's
trying to
actually
see.
really big. That's really big. That's 6 feet high. It's 6 feet tall. That's like
We're trying to see if these two triangles, stay with me, 2 more minutes. We're trying to see if these two triangles are similar using side angle side. Well, they tell us that this side is 53 degrees, this side is 53 degrees. We've got the angles going. right? Now we need to check the sides. So we have the side of 6 feet, 9 feet, and we have a side that is 15 feet and 10 feet. So if we simplify these, we get 2/3. And did I set it up wrong?
I don't know, but it better be even because whoever built it is very well built.
Yeah, they are. How could it be even 6 foot? Yeah, on. Yeah, like.
That
doesn't
It must
make
not be
sense.
flat ground. It must be a hill.
Put on one side.
Yeah.
Well, look at that.
That's where you want to build your shelter, and then when the rain hits it, just,
Look at the
If
tree.
it goes off like this way, it's like,
flood.
And you can get on top of it. And you can it is 9 feet tall, so you can get it on. Yeah.
Hey, the point is, though, we can set up with these sides that have the inclusive angle, we can set up our ratios. And if the ratios are the same with those two sides, have the inclusive angle, then we're good. We got side angle side.
So it just means that side is a bigger version of the other.
Yeah, exactly.
well, then why
job.
the ramp is
Yeah, I don't like that picture at all. Look at the tree next to it. That is a small tree right there. Yeah.
You guys are taking this way too seriously.
Yeah, because we're serious about being smart mathematicians.
What is that grass?
What is
Just not.
I was in math.
Practice, hurry! 2 more minutes, 2 more minutes.
Go.
2 practice problems done.
Is this, do we have homework?
Yeah.
We need to have, there's not a worksheet, but you need to have these done before you get the worksheet on Monday.
What's Jazz gonna do?
Jazz is gonna have some work to get done.
You should punish me.
Jazz is watching right now. He's probably listening to us.
No. Jazz, I'm gonna punish
Are you saying?
He's probably